Hi, my name is Gareth. The video I've prepared focuses on geometry, specifically three-dimensional shapes applying visualization and spatial reasoning. From Assessment 1, an area of improvement I identified was to improve my ability to visualize three-dimensional objects and ascertain their properties. Question 18 of the NAPLAN test asks to confirm the number of painted or exposed faces an object possesses. The image displays a perspective of a combination of prisms, in this case cubes. While solving a question like this can be accomplished conceptually, my video aims to demonstrate that through everyday objects, we can explain solutions to these using a physical method. Firstly, I sought out everyday objects that could effectively substitute for cubes or rectangular prisms. Seemingly, most packaging for everyday objects is kept within a rectangular prism, as it's probably considered a more efficient storage vessel. It was also noticeable that near-perfect cubes were much harder to locate. I decided to head off to the shops and bought some boxes of stock cubes. The box itself could serve as a rectangular prism, and the stock cubes could act as cubes to be formed together identically to the object in the NAPLAN question. As mentioned, the container is a rectangular prism, but also a polyhedron, and presumably this is the deliberate design, as a polyhedron is the optimal vessel for storing any smaller polyhedron shapes. In the case of this packaging, there are 12 cubes that tightly fit within a larger rectangular prism, and is formed by a 3x4 combination. After emptying the container, I dismantled the packaging of the rectangular prism. The purpose of this is to display the net of the packaging, which helps establish the properties of a rectangular prism, in particular, the faces of a rectangular prism. To emphasize this concept, I then numbered each of the faces of the rectangular prism to confirm that the net of the shape does in fact possess 6 faces. This is a hands-on example of manipulating a three-dimensional shape to a two-dimensional shape. As demonstrated from this particular net formation, the original shape can be reconstructed to re-establish the rectangular prism. This practice can help myself or any other learner understand how a three-dimensional shape can be constructed or deconstructed. This strategy provides the knowledge that any cube or rectangular prism, for example a die or a brick, always retains 6 faces. Whilst it isn't pertinent to this particular activity or question, it should be noted that the properties of a cube also possess 8 vertices and 12 edges. In the case of a cube, all the faces are square in shape and have equal dimensions. A rectangular prism faces are parallel, however not all the faces of a rectangular prism are equal in dimension. That is, the sides of a rectangular prism are of a rectangular shape and the respective faces aren't all of equal dimensions. As a means to recreate the NAPLAN question, I chose to use the individual stock cubes to refashion the three-dimensional symmetrical object by joining the individual cubes together with blue tack. From viewing the image, the shape of the object contains 7 individual cubes, hence I used 7 cubes for the task. Now with an assembled shape, I prepared numbered labels to be appended to individual faces of the object. Whilst this is time consuming, by individually labelling the exposed faces, I can ascertain the total amount of faces that are exposed and solve the NAPLAN question. This hands-on approach, adopting visualization to solve questions like this, assists myself or students understand the properties of prisms. By simply using pre-folded packaging and manipulating it back to its original form, or using stock cubes to form shapes that can act as a practical alternative to the conceptual thinking demanded from written questions such as the NAPLAN example. It even gave me other ideas regarding other polyhedrons I could find in the supermarket, the triangular prism of a Toblerone packaging for example, and how these more complicated shapes can be integrated into learning. Finally, it's important that we also compare our use of tangible objects against the conceptual or mathematical equations to confirm the logic or vice versa. To demonstrate that the spatial reasoning is confirmed, the formula for calculating it is as follows. Firstly, there are 7 total individual cubes forming the shape. We multiply this by 6, the total amount of faces that form a cube. The total sums to 42 faces. Secondly, the interior cube is completely unexposed, therefore subtract 6 faces. Thirdly, as each individual exterior cube has 1 unexposed face, this also needs to be subtracted from the total, therefore subtract another 6 faces. So, exactly like performing an activity using the tangible object, the answer also equals 30 exposed faces on this object.